Hello, this is Professor Poyser, and I am going to show you how to work out question number 37 from Chapter 5, which is on page 212 in your book. And I'll probably only have enough time to show you part A. I'll show you part B of the question in a separate video. But this is for my MAT 237 students, Probability and Statistics at QCC. And this question, number 37, corresponds to question on number 8, I believe it is, on WebAssign for you online students. So I hope this is helpful to you. All right, the question reads that a particular brand of dishwasher soap is sold in 3 sizes. We've got 25 ounce, we have a 40 ounce, and we have a 65 ounce. And it also says that 20% of all the purchasers selected a 25 ounce box. All right, that's 20% selected the 25 ounce box. 50% of the purchasers selected the 40 ounce box, and 30% of the purchasers selected the 65 ounce box. Now, your numbers on WebAssign might be slightly different, but this is the question straight from the textbook. All right, so what I suggest you do is I suggest you create a little table. And in the interest of time, I'm going to do this rather quickly. You can always pause this video here and go back if you need to. But I'm going to create a little table over here that's going to help me figure out what is the probability of somebody coming along and choosing a 25 ounce box or a 40 ounce box, okay, or a 65 ounce box, and then a second customer coming along and choosing either a 25 ounce box or a 40 ounce box or the 65 ounce box. So for example, if somebody comes along and chooses 25, the next person comes along and also chooses 25, well, I'm just going to multiply this 20%, right, times itself, because 20% times 20% will give me 0.04. If someone chooses 40 ounces the first time and the second person chooses 25, well, that would be 20, or 0.20 rather, times 0.50, which is 0.10. Right? And so if you continue with this table, you'll see that the rest of it looks like this. Now, don't be shocked by everything else you're going to see on this page, but I'm going to explain it all to you in just a moment. Okay, so the rest of that table looks like this right here. And this is easy to see. I hope you can see that, hey, if the first person chooses 65 and the second person chooses 65, well, we're simply saying 30% times 30% is 0.09, okay? Now, I want you to know that this question, really for part A, is saying determine the sampling distribution of X bar. So X bar is simply just a mean. That's this column right here. So what I did for this table down here, let me scoot this down so you can see it, is I created a table that said, all right, if the first person chooses 25 and the second person chooses 25, well, the average of those two purchase sizes, right? The average of those two purchase sizes, 25 and 25, is still 25. And again, average is simply add up these two values and divide by 2. That's how many values I have. So if you take 25 and add it to 40, you'll see that you get 65, and 65 cut in half is 32.5. So that is the average size for those two sizes of dishwasher soap. Okay, so the rest of it is pretty simple to see. 40 plus 40 is 80, and if you divide 80 in half, you still get 40. The 40 here in 65 is 105, and if you add that up and divide by 2, you get 52.5, etc., etc. So this last column then over here, this last column uses, and the way I created that last column is that I used the values that I originally came up with in this table up here in the upper right. So for example, if somebody chooses 25, let me scoot this up so you can see it a little bit better. If somebody chooses 25 and the second person chooses 25, you'll see that the probability of that happening is 0.04. So that's where this 0.04 is coming from right here. Okay, here, let's pick another one. Somebody chooses 40 ounces the first time, 65 ounces the second time. The second person does, and you'll see that that probability is 0.15. So there it is right here. It's 40 and 65, 40 and 65, and that probability is 0.15. So that's where I'm getting all of these values over here in this last column from. Okay, so then this last table that I created over here in the bottom right was simply just a way to truncate and to make all of this right here a lot shorter. Okay, all of this that I'm showing you and I'm circling here in red is really just this table over here, but just done a lot shorter. Okay, and the reason I'm doing that is because I hope you see, so I'm just kind of moving all of this stuff over here, is that do you see that 25 only shows up once in this X bar column? So its probability is 0.04, and that's what's showing up here. But look at this, 32.5 showed up here, and it showed up here, right? So it's showing up in two different places, each with a probability of 0.10. So if I add those up, the 0.10 here and the 0.10 here, I'm getting 0.20. You guys see how that works? And then, so similarly down right, 40 only showed up once. There it is, 0.25. 45 showed up twice, didn't it? 45 showed up twice. Here it is. Right, there it is. And there it is. Right, can you see that? So 45 is showing up twice. Each time is a probability of 0.06. So if I add those up, I get 0.12. Etc., etc. I'm just going to move on down. 65 only showed up once. There it is at the bottom, and it has a probability of 0.09. So this is kind of a truncated, a shorter version of this table over here. Okay, last thing then, guys, is this, and I wrote this right here for a purpose. If you refer to page 101 in your book, all right, page 101 in your book, this is coming from chapter 3, what we did a couple of weeks ago, you'll see that the expected value, capital E, is simply the same thing as the mean. Okay, it's simply the same thing as the mean. And the formula for expected value that you see on page 101 is x times its probability. Now, I know that I have x bar times the probability of x bar, but it's the same idea. If I have a column over here, which I'll call my data value, and I have the probability of that data value, well, that's what the expected mean needs. All right, so I've got x bar times probability of x bar. So I'm just going to take the product of these two things here. 25 times 0.04 gives me 1. 32.5 times 20% gives me 6.5. So this column here, guys, these two columns, I'm just simply multiplying, and I'm getting these values over here. You guys see that? So 25 times 0.04 is giving me 1. 32.5 times 20% is giving me 6.5, etc., etc., etc. And the last part of that formula for expected mean says, hey, sum all of these values up. So I'm going to simply add all these values up here, ADD. So I'm going to add all these guys up, and I'm going to get my expected value of 44.5. There it is, 44.5 for my average. All right, that's the average of the two sizes that was collected, or selected rather, by these purchasers. So that gives me part A of this question. Now part B is a little bit more involved, requires some prior knowledge. I'm going to set that in a different video. Again, if this is still kind of confusing to you, send me an email or re-watch this video here, pause along the way, and put in your own numbers instead.